So I'm going to be talking about what's coming in Go 122. And like he mentioned, Go 121 didn't come out that long ago. I want to say about a month or two ago. Show of hands, how many of you already use Go 121 at work? How many of you are stuck on an older version of Go? Okay, who's stuck on what at 120? Who's stuck at 119? Who's stuck before 119, like 118 or older? Oh, not too bad. FYI, those of you still using Go 119, that is no longer supported. It's not even getting security updates, just saying. So the point of this talk is to talk about Go 122, which will come out soon. I want to get you excited about this new version. I want you to persuade your companies to update regularly, because I think that's important. It's cool, but it's also important. A caveat, I want to talk about the things that I find interesting in the upcoming Go release. So these are my picks. They might not overlap with what you find interesting. They might. And we are 3 months away. So the first release candidate, they used to call this the first beta, but the problem with calling it a beta is that nobody tried it. But this is a human thing, so calling it a release candidate makes it seem more ready, even though it's literally the same thing. So, but nobody tried the beta, so it's called RC1 now. So it comes out in the second week of December, which is 3 weeks from now, I think. Yes, more or less. And then the final release will come out on the second week of February. And you can see that in this neat little graph that is super confusing, but it sort of shows you that they go through 2 release cycles per year, and they actually overlap. They used to not overlap, so effectively you would have the freeze in blue with, for example, in this case, we are towards the end of November, right? So they actually just freezed Go 122, like literally this morning. They sent an email saying, hey, any changes still in flight, they're dead. You have to wait 6 months. Well, you have to wait, actually like just a month and a half. But you can see the blue is Go 122 being frozen, so it's only bug fixes for 122. But then 123, it will in parallel open for development work up until May, because 2 releases per year, but they actually overlap. Most of the changes that I'm going to be talking about are already merged. Some of them are not. I will mention which ones, because even though we are already in the freeze, some things are still getting finalized. And I will share the slides with the links, because I will talk about quite a lot of things, but I will go relatively quickly. So I will only skim over the details, and if you want to learn more, just follow the links. So the first section is the language. And usually I would say, oh, the language isn't evolving because Go is meant to be stable. But in this case, we do have a few changes. They did write a blog post about how they're fixing for loops. It goes into quite a lot of detail in terms of why and exactly how they're changing. But I'll give you a very brief intro. So here's how I might write a table-driven test in Go. So you might have test foo, and then a slice of some test cases with a struct type. And then I personally like using subtests, because then you can see each result as a separate subtest entity. And then you might say for each one of them, call the function foo and check that the output is what you want first for some input in the test table. What if I want to run those subtests in parallel because I want my test to go faster? Can anybody spot the bug that I just introduced? Yeah? Sort of. It's pretty much undefined behavior, yeah. It's usually going to be the last if your loop is fast enough, but it might not. You can think of what I just showed you as this, because the way for ranges work right now in Go is that there is a variable declared. It's not really outside of the for loop, because once you reach the end of the for loop, you cannot no longer use that name anymore. But there is a single shared bit of memory that gets reassigned in each iteration. And in this case, when you call t.parallel, even though you don't see it, this runs in a separate Go routine because it's parallel, right? So effectively, you've got the outer loop starts, for example, 10 Go routines to run 10 subtests in concurrently, and then they all try to use the same bit of memory. So they effectively race with each other. And usually what will happen, like you say, is that you're only testing one test case. And this one is actually particularly nasty, because if you've got 10 test cases, you get 10 successful results, even though you're only testing the same one 10 times. So the fix here, it's horrible, absolutely horrible, is you create a new variable inside the for loop, and this effectively copies the bit of memory for each iteration, right? And you can do this neat trick where you can shadow the outer one with a new inner variable, and this makes sure that you don't use the outer one. But this is horrible. Like having to teach new Gophers about this is like, what are you doing with your life? Like, why does the language even have such a booby trap? You know. So the fix is the fix. I didn't mention it here in a slide specifically, but the fix is effectively that this happens automatically for you. So instead of test being the same bit of memory for all the iterations, each iteration gets its own little bit of memory. And you might say, well, but then that hurts performance because you're quote unquote you're kind of creating a little bit of extra memory for each iteration, and that is true. But the compiler, it's smart enough to realize if your loop doesn't actually need separate bits of memory for each iteration, it will continue using the same bit of memory. But if it sees something like coroutines, it will be like, oh, they would race over it, so separate memory. The other change to ranges in the language is that we're gaining a range over integers, which sounds really weird, and also over functions. And there is one issue, 61405, that goes into detail over that. The one over integers is like incredibly simple. It's basically just syntactic sugar. Here's a benchmark that loops a number of times that the benchmark tells you to. That's basically how you write the simplest Go benchmark that you can run with Go test. And the new syntax is literally just this. So if you don't like writing C-style loops, now you can just do that. Cool. That is possibly the smallest change to the language they've done for a while, but it's cool. The other one is much more interesting and also harder to understand, so I'll try my best. It is hidden it will be hidden in Go 122 behind a Go experiment flag, meaning that I think you have to enable this when you build Go or when you use the compiler. I think when you build Go. Because this is a new language feature that's still experimental and it's not going to be enabled for everybody by default. They still want to experiment with it and see how people like it or dislike it or break it. So let's look at an example of I want to read the user input from standard input, and I want to split the lines, right? So this is fine, but note how when I do bytes.split, I get a slice that contains all the lines at once, right? If I wanted to just go line by line, this is kind of wasteful. I'm allocating a slice for all the lines, and then I'm doing all the splitting up front before I can get the first line. Something that you might do instead is something like this. There's buffio.newScanner, and then it gives you a sort of iterator, but it's just like plain Go, a plain Go type with some methods. In this case, you initialize it, and then you do for scanner.scan. That tells you, is there another line? The .text method is give me a line, and then at the end you have to say, hey, did you blow up at some point? Because none of this gives you an error. So at the end, if it stops because of an error, that tells you what happened. So what's being added behind this experiment is function iterators in range expressions, so that for range, for APIs of this shape. And I don't know about you, but any type that's like a function that takes a function makes my brain melt a little bit. So let's look at an example. So let's look at this again for a second. Suppose that I had a function in the buffio package to mimic what I was doing in the previous slide that took a reader and returned that shape, so a function that takes a function. In this case, so what I want to iterate over is each line, an error if there's any, and this Boolean just says whether the iteration should continue. And this is called yield in the interface, you can say, because it's effectively a callback, right? So in this case, what I do is when I call buffio.lines, it returns this iterator function, and then the range calls that, and when the calls come back, it runs the loop every time with line and error being those two. Did that sort of make sense? Sort of. So these yield functions, they're kind of like in Python or in other languages where you call something and then it calls back to you, so it yields back to you. And Ross, who wrote this proposal and is one of the leads in the Go project, calls this push iterator, because with a pull iterator, you call it to obtain some the next value, like for example with the current buffio scanner API. But with a push iterator, you call it, you give it the power, and then it pushes the values to you, in this case via calls. So you can think of it as like it's syntactic sugar for callbacks back and forth. There is another proposal to extend this work to make it more powerful, to add an iter package in the standard library that gives you things like, for example, converting a push iterator to a pull iterator. And that does that with coroutines, which are kind of like Go routines, but cheaper. That's about as much as I understand. If you go and read and follow that issue, there is a blog post that Russ wrote that goes into lots of detail with diagrams and does a much better job than I can ever do at explaining what coroutines are. So I might have lost some of you with these language changes, but it gets a little bit easier because now we get out of the abstract new features stuff and we talk about the toolchain. In this case, the toolchain is the compiler and the linker and basically anything that runs whenever you run go build. One that's being deleted is go path mode get. And by this, I mean, do you remember when you used to run go get and it would git clone something in your go path? Actually, how many of you remember a go path where it would have like projects checked out, you know, in github.com/blah, blah, blah? Yeah, feel old, eh? So this, nobody should really use it anymore because in modules mode, which is the default, it's been the default for like, Jesus, half a decade now. So this code path has been disabled by default for some time. Now it's being deleted. Hopefully none of you are upset about that, but if you are, maybe don't say anything because it should be deleted. Another change is that Go 122, to build itself, Go is written in Go. It will require Go 120 or later. So they started implementing a policy a couple of years ago where every 2 releases, so once a year, they bump this minimum because the problem was that before it always built on Go 1.4 and Go 1.4 came out, I don't even remember, pre-COVID. It's very old. It's, I want to say like 2012 or 2013 or something. And the problem was that the compiler couldn't use any of the new features and had to work around old Go bugs and so on. So now they're keeping the 2 in sync once a year. You can also, nowadays you can run Go mod vendor and it vendors your dependencies on the module, but you've got workspaces, which are kind of funky, where you can make a collection of modules and then have them all depend on each other on disk together. Workspaces are a bit confusing. If you know what workspaces are, the TLDR is that you can now vendor for a whole workspace as well. That's basically it. I think it's Go work vendor, so it's fairly easy to find. If you like profiles, in this case, for example, CPU profiles or memory profiles, like with pprof, there's something called a mutex profile that tells you why your program is blocking. So now that profile counts your blocked coroutines correctly. It used to not do that, and nobody noticed for years. So maybe that tells us that mutex profiles aren't very popular, but they do exist, FYI. There's something called PGO since Go 119 or something like that. And it's basically you collect a CPU pprof profile, and if you include it as part of your Go build will be optimized for that profile. So for example, you can, with the profile, you can tell it, oh, this loop is very hot, it runs very often, so please try to optimize it harder when you compile. Because a compiler always has this trade-off about how long do I spend optimizing the code? Because if you spend a ton of time optimizing code, you end up like LLVM or GCC when they build C++ code. You know, it takes forever to build. And Go is the opposite by default. But with PGO, you can tell it, oh, actually, just spend a little bit more time in these places that I care about. So now with PGO, Go 122 can do more things to better optimize your code. And one of those things is called devirtualization. And what that basically does is, if you've got an interface value and you call a method on it, what that ends up doing in the binary is that it has kind of like a lookup table to find out what type it needs to call, right? Because an interface method, it's not code, it's an interface. It's like, you know, it's magic. It magically goes to the right to the right function body, but the function body is on a type that declares that method. It's not on the interface. So there's that indirection with a table to go look up the right function body to run. So devirtualization is, if you know that the type will more often than not be this one particular type, it will effectively do like a little bit of a quick path of like a quick check of trying to go there first, and if it's not, then go back to the table. So it's effectively like a shortcut for the common case. So this actually helps a ton more than you might think. If you're reading, for example, if you're reading a lot of bytes from a file, and you do that through an IO.reader, this could avoid an interaction through an interface, and this could make your reading potentially twice as fast or something like that. The inliner is also getting a lot better in the compiler, and the inliner is basically when you call a function, it can just put the body in your own function, and that again saves CPU cost. It saves overhead. And the inliner in Go has been kind of basic for many years, and now it's being properly overhauled. And if you follow that link, there is a very cool design document where they explain how they're designing the new inliner. Because Go is actually a bit special compared to most other compilers, because again, in Go, the compilation speed is one of the key design decisions. So they don't want to spend a lot of time computing stuff to make your program faster. They want to strike a bit of a unique trade-off between those two. And the last section is the standard library. So these are changes to the APIs from STD that you might use in your projects. One that's maybe the most exciting and also controversial is enhanced servmux routing in NetHTTP. So basically, when you declare an HTTP server and you declare routes that should do something, this is getting more powerful now. Suppose that before, so in Go 121, you can have /hello going to a handler function that takes the response writer and the request, and you might say hello path. So far, so good. What if you wanted to only do that on GET requests? So you might do something like this manually because there's no built-in support. And what if you want to take an argument, like for example, /hello/foo? Then you might trim the prefix. Like it's starting to get a little bit wonky. And this is why it's fairly common to use third-party routing libraries like Gorilla or Chi, or there's plenty of others. So we are getting, it's not new API, except for this path value method. It's still the same handle function, but the string parameter that it takes has been overloaded to also accept more things. So now it accepts an optional method prefix separated by a space. So that's pretty much the same syntax that you would have on the HTTP plaintext protocol. And then it also accepts this curly brace variable syntax. So in this case, I can say get hello/name, and then when I get called, I can retrieve what that name was. So like Daniel or Tom or whatever other name. Another one that's quite exciting is we've got math/rand, but it's kind of like a minefield of misuse. And it's both not easy to use and relatively easy to misuse, if that makes sense. So for example, it's relatively easy to read from it. And you might do that to actually get some entropy. And some people can do that without realizing if they use something like Go imports or Go place to fill imports. Whereas in fact, math/rand is not good for that kind of thing. So the new API is safer. It's also faster because they use new algorithms for pseudo-random number generators, if I said that correctly. But it's also a lot easier and safer to use. There are a lot of design decisions in V2 that differ from V1. I'm not going to go over them because I don't want to put you all to sleep. But if you follow that link, there's a lot more detail in there. There's also Go/version, which is operations on Go version strings. And again, looking at an example, semver is things like v1.2.3 or v1.3.0-RC1, right? But Go doesn't use semver for its versions. You can have Go 120, you can have Go 121.0, and the RCs, notice that they don't have dashes and they don't have dots. And you can also have like a development build that's like dash and some string, right? So some of these, like this one, kind of look like semver, but this is not semver. So now this Go/version API in the standard library, it allows you to, for example, compare these versions. So which one is bigger or smaller than the other, which is something that you can do with semver packages, but these two weren't compatible before. So now you have similar API for Go versions. This one's another tiny one. Now we have generics. So they've started using them for some of the packages. And a common request was, in SQL, you can have nullable columns in your schemas, right? In your databases, in your tables. And you do have null string and null int and all these types, but you've got generics. So why would you do that nowadays, right? So now you've got null of t. It does the obvious thing. Super exciting. Another one is encoding. They called this append-like variants, yeah, of the APIs. So I'm going to show you an example. So before, currently, you have things like, for example, base64 encode. And encode takes a destination buffer and a source buffer. So in this case, you want to encode what's in source, and you want to put it into destination. But you have to, there's two quirky things about this. One is that you need to make sure that destination is big enough. And the other one is that it's sort of wonky to use properly. Like, for example, you need to make sure that the length that destination ends up with is correct as well, because this doesn't return you a slice. So, for example, suppose that you want to encode a string into base64 and then quote it, right? So what you can do now with append encode, which looks like append because it returns the final slice, you can do this, which looks extremely similar to the other append calls. So it's a lot easier to use. If any of you know what the netip package is, it's got compare APIs to compare with other netips. If you don't know what netip is, I'm going to skip over this because it's fairly specific. So I don't think it's worth spending time on it. You can also add an entire IOFS into an archive tar file now. So before, if you have an IOFS, like, for example, from a directory or from a zip file or from whatever else, that allows you to read a directory tree with files. If you wanted to compress that into a tar archive, you would have to loop yourself and do all that logic yourself. So now they came up with this API where it says addfs, and then it just like puts everything in there. It's like a copy, like a recursive copy operation. If any of you write Go tools, there's an AST package to look at the syntax tree of Go source. There is an object type in there. You should never use it because it's broken. It's been broken for years and years and years. Now it's finally deprecated. If you don't know what it is, great. Don't find out what it is. It's broken. Another one for tool authors or static analysis authors is that there's a new info.file versions field. And what this does is it tells you what Go version each Go source file is built for. So for example, we can do //go:/build and then Go 120. And then that tells the Go compiler that this file is only for Go 120 or later. So this API allows you to retrieve that information. Go types also keeps track of alias nodes now. So you can have alias types in Go. So type foo equals bar. That equals what makes it an alias. And if you wrote tools or static analysis tools before, those aliases would be completely invisible to you if you use the Go types API to type check the Go code. So now, with Go 122, I actually believe this is behind a flag. I don't think it's enabled by default yet. But now you can actually see what the aliases are, which is really important to, for example, give good error messages. Because if I say type foo equals bar, and there's a problem with foo, I want to tell the user that the problem is in foo, not in bar, right? So that because the user sees foo after all. Another one is more IOFS. So from NetHTTP, you can now serve from an IOFS. So you have APIs like serve file that takes a path to disk, but now we have IOFS, so you can use an IOFS instead. And for example, you could serve from directly a zip archive, or you could serve from memory, you could serve from whatever you want. It's more flexible this way. You can also concatenate slices. So here's one very silly example. That's the API. It's generic. So it's basically a list of slices as a parameter. And then suppose that you get standard output and standard error from some command, and you split the lines, and then you concatenate. So this is a slice, this is a slice, and then you end up with a slice whose length is those two added up, right? Pretty simple, but useful. Another one is reflect.type4. So basically, you've got this package in Go called reflect, and it's for type reflection or also value reflection. And something you can do is, for example, load the type of a Go value at runtime. And you can, for example, obtain the type of a Boolean or an int. And you can do that. You need to pass it a value, right? Because in Go, you can't really pass types, at least not before generics. Something you could also do is, the problem with the first example is that you have to remember some valid value for that type. So for example, false or 0. If you want things to look somewhat consistent between types, you can use pointers, because new always allows you to pass whatever type. It still works. And then .lm just dereferences that pointer, because I don't want pointer to int, I want int, right? The problem with those is that all of those allocate. The first ones allocate because typeof takes an interface, and interfaces in Go, the value is always a pointer. So even though false is not a pointer, it gets allocated, and you get a pointer to false, which is really silly, but it's how it works. And then these, of course, create a new object, so they allocate. So what people usually do is this horrible, horrible hack, which is a typed nil pointer, in this case, whose type is pointer to bool, and then you give that to typeof. It's the same as this, but instead of the pointer pointing to some random new memory that you just allocated, it's a nil pointer. But this is the typical gotcha. It's a typed nil pointer, not an untyped nil pointer. And if you don't know what that difference is, it will bite you someday, and then you will find out how fun it is. But now with type 4, it's generic. So effectively, it implements this, but you just pass it the type parameter. Great. A lot easier. I don't have to explain all this background. You just do that, and it does the right thing. I will finish with another silly one, but which I find is surprisingly useful. I've written this kind of code multiple times before, which is, suppose that I want a global variable to be configurable via an environment variable, but then if that environment variable is not set, fall back to some value. So for example, target host for some program, and if not, localhost, right? So the code does the obvious thing, but I've written stuff like this multiple times before. So the package comp, which is new since we got generic some time back, it has some helper stuff. So one new bit of helper API is OR. It takes a list of comparable values, and it returns the first one that's not its 0 value. Does that sort of make sense? So in this case, I can do comp.or with getenv and then the fallback. So if this is non-0, it will use that one. If not, it will continue to the next. And this is a list, so I could actually put 7 things in there if I want to. But it's also more general. And a parting thought that I had here is that skimming the commits that hit Go master is actually pretty helpful, because they write really good commits in Git. And I think if you want to learn about how Go works, or how it's being changed, or just how they do things, or what features are coming, it's pretty interesting. You don't have to read everything. You can just like skim it, and then if something sounds interesting, read all of it. And you don't have to wait for Go 122 to be released, or even the first release candidate. If you run that command, and then run go tip build or whatever else, it will use Go master as of today. So you can test whatever you want out of these new features that I showed you, and file bugs and test it, and be a good user. And that is it. So any questions, I'll be happy to answer.